Welcome everybody to this class. Today we're going to be looking at the concept of stress. The concept of stress. And the first thing you're going to do for me now, ensure you subscribe to this channel and turn on our notification bell so that anytime we release any video, you'll be the first person to see it. So what is stress and what are the concepts that follow stress? Now, in strength of materials, stress is a very important element or a very important quantity that we should take a high reference to. And we also have something that is called strain. That's what we're going to study both of them together: stress and strain. Now, what is stress? What is stress? And what is strength? Now, strength is what complements stress. The strength is what complements stress. So how do we check whether the material is strong, or how do we check for the strength of the material? We check for the strength of material by calculating the amount of stress they can withstand. Stress is the problem, strength is the solution. Strength is the complement. So when we are looking at the strength of materials, actually we are trying to resolve the stress these materials can undergo. There's what we call bending stress. There's what we call axial stress, tensile stress, coming from tensile forces, and so on. Compressive stress, going from compressive loadings, and so on. Now, if a material is loaded, how does it respond to the effect of the load? That will determine the strength of the material. Now, you should know how to calculate stress, because if you can calculate the stress the material can take before it fails, then you know how strong that material is. So stress is force divided by the cross-section area. That's axial stress. Stress is actually defined as force per unit area. Force per unit cross-sectional area. So stress induced in the material is equals to force in the material divided by the cross-section area of that material. Especially when we are looking at something like the axial stress. Acting at the cross-section to the material. There's also called shear stress that's coming from all the shear forces. That is different from, although they are still force over area. That will be shear force over area. We're not looking at surface area and so on. Now, there's another called bending stress. We're looking at that bending stress in our other classes. Today we are just going to look at axial stress from axial loads. Axial stress from axial load. Now, we already said stress is force over area, and let's assume we want to calculate the stress in a particular material. Now, let's take a question. Now, please ensure you know the type of stress we have and this general formula for stress. And in the next class, I'm going to look at stress-strain curve to form a geometric property or a property of something like a particular material or of a material called the Young's modulus. It's a material property actually, and we have what we call material properties. Also, what we call geometric properties. Now, material property describe the strength of a material, while geometric property describe the shape of that material. For example, now, area is a geometric property, force should be a material property, stress is a material property, something like section modulus is a geometric property, the volume of a material is a geometric property, and so on. Something that tells us the shape of the material, tells us the geometric properties of that material. But the material property tells us how strong the material is, how strong, like stress, Young's modulus, shear modulus, and so on. So let's look at this question. Let's take this question and see what we're going to have. Now, calculate the stress induced in a material. Calculate the stress induced in a material. Calculate the stress induced in a material of cross section. That is 500 millimeter deep. 500 millimeter deep. 500 millimeter deep. And 200 millimeter wide. 500 millimeter deep and 200 millimeter wide. If the force exerted on this material, is, or if the load exerted on this material is 10 kilonewton. If the load exerted on this material is 10 kilonewtons. So, you said the cross section, the depth is 500 millimeter, the width is 200 millimeters. So you can also see something like that as a cross section. Here is the depth, and here is the width. So, the next thing we're going to do for me here is to calculate the area. Area, you can this something like a rectangle. Area of the rectangle is length times breadth, or depth times width. So you're going to have 500 times 200. But this 500 is in millimeter, 200 is in millimeter. I'm going to convert it to meters. So when you convert from millimeter to meters, you divide by 1000. Divided by 1000, you're going to have 0.5 times divided by 1000, you're going to have 0.2. So 0.5 times 0.2, you are going to have something like, let's say 0.01. So let's double check this times this. Okay, let's check. 0.2 times 0.5 times 10. That's 10. This is 10. That's 10. So this all times this is 0. This times this. That's 0. 0, 1, 0. So I have two decimal places. So 0.1. So let's check what we have here. 0.5 times 0.2. That is 0.1. 0.5 times 0.2 is 0.1. So that gives us 0.1 meter squared. So our force is 10 kilonewtons. That is going to give us 10 times what is kilometers per 3 newtons. So the stress will now be equal to force, which is 10 times 10 per 3 over the area, which is 0.1. That gives us 10 times 10 per 4 Newton per meter squared. That will be the stress induced in that material, and the other stress induced in that material. So in the next class, we're going to be looking at how to calculate primary stress, secondary stress, and how to draw the stress strain curve.